Hey, Trevor Matthews here with another morning coffee with Trevor. Thank you so much for joining. Today we got lots of interesting comments and topics that we're going to talk about. We're going to dive in probably mostly into compressor loss of oil. I want to thank everyone for their emails, their requests, and their questions. It's totally helping out. And thank you so much for everyone joining these sessions. Today is Sunday, and I love just hanging out, talking refrigeration and having a coffee. So it's very enjoyable. So over the last 4 days, we talked about contamination on the first day. We dove into contamination. We got into overheat on the second day, talked about what causes overheat in compressors. We got into flood back on the third day. Talked about some things that cause flood back, as well as yesterday we talked about flood starts. And what causes flood starts today. I think we'll get into compressor oil loss and what causes that. But welcome everyone. Good morning. How you guys all doing?
Doing good.
Awesome. Thanks for joining.
Good morning.
Good morning. Yeah, so we're going to dive into a bit about compressor oil loss today, but how's everyone's morning doing? You got yourself a coffee? Where are you guys all from?
I am from Aruba.
Aruba. How's it there today? What time is it there? Is it 6:32?
7:30.
7:30. Okay. Now you're at Eastern time or Atlantic time here. So cool.
Yeah.
Well, thanks for joining. I appreciate that.
Thank you. I appreciate you doing this.
Oh, hey, no problem. Hopefully I can share a little bit of knowledge, get a good conversation going, and that we all can learn a thing or two, because I've been doing this for 4 days now and I've learned so much, and I had so many people reach out to me and shoot me questions and messages and saying thank you. So really appreciate that from all of you, and even taking the time. It's Sunday and you're taking the time to come and listen. So I really appreciate that. Hey, Brett, what's shaking, brother? Okay, so we'll get into we'll talk about some compressor oil loss and some of the things that cause that, because I think that's very important. Something that was one of the most difficult things for me to troubleshoot, and it still is something very difficult, is loss of oil, especially if you don't have sight glass. But even if you do have sight glass, when a compressor loses oil, what causes that? And there's so many different factors that can cause that. You know, it could be from a leak, where you lose the oil at the leak. So first step when you're doing a troubleshooting situation and there's no oil in the sight glass, you should look around to see if you can find a leak somewhere, because it could have blown all out there, right? You may not have much refrigerant in the system, even if you don't have a PLC or something to look at it, the EMS, energy management system. So you want to make sure there is no leak before you determine, okay, well, it's stuck in the system, because it may have lost it there. And like I said, especially if you're on residential stuff or you're on self-contained stuff, or even condensing units without sight glasses, you need to check for that first. Oil also can be logged. You know, you log it in circuits in an evaporator. I've seen it many times in the field where either I was doing a reno or I was on a job site, and the piping was not piped properly. I didn't know that at first, but it was logging in an evaporator, and that evaporator would not be cooling properly, because the oil, you know, stops that heat transfer, prevents it from the heat transfer, right? Because if you're filled up with oil, you're not getting the proper heat transfer you need. So it's something you need to look for. You make sure your piping flow properly, because if you don't have oil, you don't have that lubrication at the compressor, you're going to cause that compressor to damage. Not necessarily always fail, but if you lose all your oil, it's going to seize up for sure. But over time, if you don't have oil, it's going to cause more heat, right? Because you get more friction happen. You don't have that lubrication, lubricity, whatever you want to call it. And it does lead to damage, which leads to a failure. I've seen lots of them. I've troubleshoot lots of them, and I cut open a lot of scrolls and semi-hermetics where they were damaged from loss of oil. And loss of oil can happen in lots of different ways. It could be overheat that caused loss of oil, because if you overheat the oil, you thin it out. And when you start to thin it out too much, you lose that lubricity or lubrication properties. And then if you heat it up even more, then it really breaks down. Other things that cause loss of oil is like the suction lines themselves. Are they designed properly? Do you have too big of a suction line and not have the velocity? Have you not piped it a trap in? Do you need a trap? Do you need a reduced riser? Do you need a double riser depending on your application? And we're seeing more and more of these applications where you need double risers when you're adding, say, a variable speed drive to a system. Because when you start to reduce the hertz, or you reduce the speed of that compressor, you reduce the mass flow and the way that oil moves through the system and that refrigerant moves through the system for cooling of that compressor. So you'll see on systems that have a VFD where they may have inputted an oil boost cycle. So if you run below a certain RPMs for so long, all of a sudden that VFD will ramp back up to full speed to make sure you're getting some oil flow. Other things that cause oil issues is restrictions. You know, you can have a restriction in the oil line. You could have a restriction in the accumulator. I've talked about this many, many times. If you have a bad burnout, that if you have an accumulator in there, there's a little orifice and a little screen inside there that could plug up. And it may not plug up right away. It may take some time, that if the system wasn't cleaned properly, and say you didn't change the filters, for example, the liquid line filter, and didn't put a suction line filter in there, that would pick up some of the dirt and start plugging that screen or that orifice in there. So that's a few of the things that cause it. Another one, probably short cycle, is another big one that I didn't think of before, especially even the first 5, 6, 7 years. Short cycling happens. Okay, the compressor starts up and shuts down. Okay, so you think it's starting to overheat because you're starting up a big winding in your stator, so it is started causing more overheat in that compressor. But every time you start out, there's a pump out rate. So what happens? It pumps out a little bit of oil, and if you short cycle so much, it's going to pump out all that oil, and you don't have enough runtime, because you need runtime to pull that oil back to the compressor. So if you don't have any of the runtime, that's one of the reasons that compressor manufacturers kind of put a limit on how many times they would like their compressor start. That's one of the reasons they don't like to short cycle compressors, because it's a lot of work on it. It's a lot of hard work on the compressor. But that's one of the big reasons that they'll say, oh, we only want it 6 times an hour, 10 times an hour, 12 times an hour, the compressor to start. And you're going to see different manufacturers say different things, and even the same manufacturers say different things depending on their compressors. Semi-hermetic is going to be different than a scroll, and different scrolls are going to say different amounts that they would like to see. But what you don't want is if you're cycling more than 3 minutes, you turn it on and turn it off within 3 minutes. You should put some sort of timer in there, some sort of device that's going to stop it from short cycling. And you need to look, why is that even happening? Was it designed incorrectly, the system, in the first place? Did something change in the system now that compressor is oversized? And so you need to think about this. What's the control strategy? Maybe it's on a multi-compressor system and the control strategy is off, or it has changed. And it's important to understand this stuff. And you need to learn it overnight? No, but it's the stuff that you need to think about and review and check, because oil inside the system, you don't see it all the time. You know, you don't see what's going on in there, but it's should be always moving with the refrigerant, or always staying at the compressor, you know, because in a parallel rack application, you have a separator and you have a reservoir. So you do not want the oil to be traveling through the system, because the more oil you have in the system, it potentially can be the less efficient system. Because if your condenser is full of oil and your evaporator got lots of oil in it, you're going to start to not either reject the heat as much, absorb as much heat as you want. So that's other things you want to think of, because if you have too much oil in the system, why? You should have just the right amount of oil in the system to make sure you maintain the lubrication at the compressors. I'm talking a lot there. Anybody have any experience with oil issues in their systems before?
Once or twice.
Once or twice, I'm sure, Brett, eh? Once or twice?
Yeah. You know, we one of the craziest ones I think that we ever had was basically we had a store that went under a recent remodel, and shortly thereafter, the oil problems after oil problems after oil problems. Person would shut down the system, let everything rise up for a bit, turn the system back on, then all the oil would return. Since all the compressors were running, it would run good for a while. And as soon as the load would come back down, all of a sudden we started losing oil again. Come to find out, when they did the remodel, they didn't take into effect of what happens to a centrifugal separator. Basically when you cut load off of it, and basically because that did not have the proper amount of discharge CFM on it, we ended up having to put a coalescing filter in there, which is a lot more forgiving as far as, the difference between, max discharge CFM and what it will still operate. The helical or centrifugal ones, they're, once they get down to about under a 2/3 or 1/3 of what their rated load is, they don't separate oil with a dam.
Yeah, and that's a great point, because I was talking with a manufacturer here, a good friend of mine, Pierre Levesque from Septec Technology, and he builds CO2 systems, transcritical. And he says he had a contractor call him out on somebody else's piece of equipment, because he's very helpful and he helps so many companies in Quebec and all over Canada. But he went out to a site and they were having oil issues on their transcritical compressors, and they just couldn't figure it out all the time. The compressors were tripping, the oil wasn't coming back. And come to find out is that the temperature was running too high in the oil. So your oil separator is only going to separate oil at specific conditions. Now, if your oil is way too hot, too thin, like I mentioned earlier, it's going to bypass that separator, and then you're going to run into oil issues. We got another question here from Costa. Sorry if I didn't pronounce your name. I've heard that manufacturers have a max of 5 or 6 startups per hour. How do they control this? Okay, so I don't know if I did answer that question, because I've just seen it in the chat. Well, depending on the manufacturer, like I said, they might say 5 or 6, they might say 10 or 12. Okay, depending on the compressor. But if they say 5 or 6, so that's really, they want you to run like 10 minutes or off for 10 minutes. So if you run for 10 minutes and off for a couple minutes, that you're getting the flow of that oil, the refrigerant, you're keeping that compressor cool. If you run into issues, you're short cycling, you really want to figure out why you're short cycling. That's step one. You don't want to figure out how to fix it yet. You want to figure out why it's short cycling. Were you working in a supermarket and they took glass doors and they put it on all the dairy cases? I've done that many times and I didn't know why. And I remember going into the rack room and compressors banging on and banging off. And it was because you just dropped the load off. You go from 500,000 BTUs down to 200 or 300,000 BTUs on that rack. And so you want to figure out first, why is that happening? Why is my compressor running 12, 15, 20 times an hour? And that's step one. Is the contactor losing power? It could be a power issues where you're dropping voltage on your contactor, and that could be it. And that's just one example. And what you want to do is that if you figure out, okay, the compressor's oversized, well, what do I do? What are my options? Well, you could put a time delay in, but then it's going to affect the temperature of that box or whatever you're trying to pull out, like the coil itself. So now your temperature is going to be swinging up and down. If you put, say, a time delay in, say, okay, if it's short cycle for every 3 minutes, okay, let's put a 5-minute anti-short cycle delay in. But you bang on this big compressor, pulls the temperature and pulls all the heat out real quick, and then shuts off again. So it rises up, and then you're going to have big temperature swings. So then you want to think about, well, what can I do? Can I add a digital compressor to that compressor itself? Can I add a VFD to that compressors? Most people don't know, but you can add a VFD drive to most compressors out there, but you need to figure out what the limitations are. Can it go down to 25 hertz? Can it only go down to 35 hertz? Can it only go down to 45 hertz? And this is where you got to go into the manufacturer information. If it's Copeland, Bitzer, Danfoss, whoever it is, Carlisle, you need to go in and check what's the limitations, because the limitations could be that you don't set it properly, you run outside the envelope, you don't get the oil back, or you cause damage to the wines. And I've seen this in some applications that I've a part of, where we didn't set the high trip rate, so the amperage. So the max continuous current or the max amp operating amps was 5 on that compressor. It was set to 16 on the drive. So anytime we were above 5 amps, the drive wouldn't kick out, wouldn't trip on alarm. So we were just pounding voltage and pounding electricity to that drive outside at the windings range and cause it to premature failure. After a few months, it failed. And that was because of not understanding what the values we were supposed to put into the VFD drive. Hopefully that answers your question. So make sure you figure out what's causing the compressor to start more than 5 or 6 times an hour. And then you could do a time delay, add a capacity control device on that compressor to try to help reduce that, or replace the compressor to the proper size compressor. But that's not always the case. You can't always do that. Velocity is something that's really important to think of. As a technician, we don't think about that a lot. Like as an engineers, like I work with lots of engineers, they understand that stuff and they think about that all the time, because they need to make sure that the speed that refrigerant's going through that pipe, going to that condenser, going to that evaporator is correct. So you size the piping properly. And so you're getting the proper amount of velocity through for your mass flow, for your cooling, for your removal. And when that starts to change, or you don't pipe it properly, that's when you can get into trouble. And as technicians, I really believe we need to spend more time learning about pipe sizing, because I was there. I was a technician where, oh well, this manufacturer spends millions and millions of dollars on R&D and research and development, but it doesn't mean they didn't make a mistake. Like the engineer could have wrote down on the piping schedule or the legend, say he wrote down 1 and 1, but really it needs to be a 1 and 3, or it needs to be a 7/8. And I've seen this a lot on defrost system in coffin cases where return gas defrost should be 7/8 header for the defrost, and we were putting in 5/8. I didn't know the difference. And then we started struggling months down the road for defrost in case we're freezing up. I had to go back in and add and change it from a 5/8 up to a 7/8 a defrost header. So these are just things that you learn over time, but you need to think about the different application, and pipe sizing and stuff. I think is very important. Is it a pain to learn? Yeah, it can be. Is it hard to learn? Yes, it is. But when you learn the hard things, that makes your job easier. It definitely makes your job easier. I got a question here. Slowing the velocity could reduce the capacity of the refrigerant to carry oil back to the compressor. For sure. For sure. That's why in like variable speed systems, they'll have, like I said, oil boost cycle. And one example would be if it runs below 1800 RPMs for over 2 hours, that they'll do 5 minutes at 3500 RPM. So they'll ramp it up to full speed for that amount of time. And there's different processes, different manufacturers, but as technicians, you need to learn that. And this is super intimidating. I talk to so many technicians that go out to a site and there's a drive on it, and they tell me, like, I just bypass it. If I'm on call, I'll just put it in full drive, get the system up and running, and then I'll go home. But they don't come back and assess it. And when they do, it is difficult. Learning drives is not easy because we're used to mechanical stuff, fixed compressors. It's not easy. I'll tell you right now, I worked on lots of them when I worked at Emerson, and we had some in the lab, and it wasn't easy for me to learn. And I've worked on lots of them, and I feel like a novice on them. But what you need to do is spend the time to learn those parameters, the different parameters and what exactly those parameters do. Because I find that this is a lot of things that technicians skip. They read something, they're like, okay, this proportional band. Okay, what's that mean? Well, you need to figure it out if you don't know what it means, and all these other ones. So what's the max RPM? Well, max RPM is the top RPMs it can run. Okay, minimum RPMs it can run. In hertz, what should it be? You need to understand how to do that. It takes time and it's hard. It's not easy, but you need to spend the time little by little learning those hard things to make your job super easy. Your job's so much easier because there's going to be drives on, let's say 80 to 90% of the equipment's going forward, or some sort of capacity control or some sort of control system. Electronics is going to be on every system. At some point, it's going to be all electronics because it makes it easier. On these little tiny systems, I don't see it, in your fridge. You're still even seeing it on your fridges now in your house. If you have an expensive fridge, there's electronic boards on them. They're going to start having drives on them. But on condensing units, air conditioners, residential units, we're seeing it already. ECM fan motors, we're seeing, variable speed on the compressors, and two-stage or digital, depending on what application, but we're seeing it. And it's going to get more and more like that. So you got to get in the mindset, let's learn the new technology and how to figure out. Don't have to learn it overnight. That was one of my problems. I used to think, oh, I need to learn this now. No, take time to learn it. Say in the next 6 months, I want to learn how the digital compressor works, or I want to learn how the ABB drive works with a compressor. Because one of the most intimidating parts is that there's just so much, oh, it's a 1,000-page book or it's a 150-page book. Well, that's part of our job, learning that stuff.
Trevor, if I could, I wanted to touch on the piping that you were talking about.
Yeah.
So right now, currently, we're having an issue on a Cascade rack, and on the expansion valves, we have a whole bunch of pulse width modulating expansion valves, basically ported solenoids. And on the heat exchanger side, we're getting really erratic superheat, anywhere from 3 degrees up to 20 degrees. And you can see the liquid level just plummet. And, my guess is the fact, because on a liquid line, you have to have a proper velocity in order to keep that full column of liquid. I don't care if you have 40, 50, 80% in that receiver. If that velocity isn't where it needs to be, you will have a considerable amount of river. That being said, after further, investigation, we found that the electronic expansion valves, because the suction pressure is so low, it's causing all the electronic, pulse width valves to basically not feed. And because they're not feeding, it's causing barely any load on the, on the high stage side of the Cascade, and then in turn causing the rivering, which then is causing the erratic superheat on the Cascade side, which then is causing, the discharge pressure on our CO2 to run very high because it's not getting that constant amount of superheat. Would you agree with that?
Yeah, it sounds correct. I would have to look into it a little bit more and write it down and look at it on a actual chart. You know what I mean? I never had to do that before, but now it kind of, it does make sense to me, what you're explaining there. And I never came across that myself. So it'd be nice to talk about that a little bit more in detail to get a better understanding, and I draw it down. I find that what helps me a lot more now. I never really did that until like I was 7 or 8 years in the trade, where I would sit down and draw piping schematics, and just understand what's going on in the system, what direction it's going. So we'll take that offline and maybe come back with it in another morning and talk about it, Brett. Something else that I didn't mention about oil is that floodback. Floodback could come back, and a lot of people call it washout. Oh, my compressor was washed out. Well, that's another reason why you can have low oil in a compressor. You get washout happening, and you come into a site, and then all of a sudden you're tripped on your core sense or your Centronic or whatever the oil level control is, if it's a pen. That compressor was washed out from liquid refrigerant, so you had floodback come back, wiped it right out. Another one that could cause it is blow-by. So if you have a damaged compressor, blow-by happening, what really happens is you have a lot of discharge going into your suction, and inside, say Copeland 3, 4, and 6Ds, 2Ds, I think 2 as well, they have a check valve in between the body, so where the stator is, and the crank. If you have blow-by happening, say from overheat, and you have damaged rings and pistons, it's going to push pressure in the crank, closing that check valve. So the compressor is going to run, and all of a sudden it's not going to have its pressure differential of 7 to 9 psid. Compressor trips off an oil failure. All of a sudden the pressure equalizes and fills that compressor back up. So you got to, sometimes our job is to look inside these compressors. If the compressor is tripped off or it's tripping the breaker, well, like we talked about, you need to figure out what's going on. And if you get to the point where you need to look inside, don't think, oh, I don't want to look inside. No, that's our job. Pull it apart, look inside, get the gaskets, put it back on. So things to prevent oil loss, you need to check the slope. I think it's every 10 feet, it should be a quarter inch drop. I'll have to look it up. Every 20 feet, half-inch drop. And I should remember, get the metric numbers as well. Proper trapping, proper piping, like we've talked about for velocity, prevent liquid floodback from washing out. check for leaks, as well as contamination. You know, that filters, you know, it could be a filter, suction filter, could be accumulator, all these different things that have dirt inside the system that could plug up maybe that oil pot or the OMB, OMC, OM3, M4, M5, could be that oil filter. So all those different things you need to check. And is it easy to do? Not all the time. Do you need to sometimes go up into rafters, take a look, check with your visual to see if it's sloping properly? Yes. Does it take time to do it? Yes. That's part of our job to figure that stuff out and take the time to do it. Do have a couple questions in here that I don't see. Just to think, if the discharge pressure is discharge pipe is small or not sized properly, the high velocity refrigerant could move the oil into the compressor. And when the suction line is oversized, the oil could not go back to the compressor. So the oil might be stay anywhere on the other side parts of the system. Yeah, so if your suction line, if your velocity is not correct, if you have oversized suction line, you don't have enough velocity to pull back. If you don't reduce, say, the riser, and there's a Copeland has a good book, good manual. It's a refrigeration piping manual, an installation manual. It's on. I'll look it up. I'll put it in actually into the YouTube video. But that's what I learned on when I went to school. I went to a school here, quite a few schools, but I learned out of that book how to do piping. But I never looked at it for many years until I ran into a situation, and we used a DuPont book, line sizing book, and that Copeland book. But I'll put it in the notes of this one to help people out. If your discharge line is too small, then you're going to probably, and I've heard of this before, is where if you can't push that discharge out, it's going to put a lot of pressure on that compressor, and you're probably going to start tripping off on internals on that compressor, say a 346D. We have to change refrigerant in a refrigeration system from R22 to 410. How can we clean an evaporator from any oil? Okay, so if you're going from R22 to 410, you're going to have different line sizing. So it's really you're retrofitting the whole system. If you were saying 407C, you could use those line sizes. You need to do the mineral, the POE oil change. You need to make sure you have 95.5% POE to mineral oil. But when you're going to 410, that's different velocities. So you're changing the piping up. I would really, we are going to change the pipes. Okay, fantastic. So the big thing, if you're changing that, also you need to make sure the compressors are rated. I think Copeland rates discus compressors for 410. I haven't really checked Bitzer, but I can check Bitzers. I'm sure they do have some for 410, because way back when we had those refrigerant regulations 20 years ago, they weren't sure. They spec 410A for refrigeration application, because you see it 90% in air conditioning application. We see this in yeah. So you need to change that oil. You need to make sure the oil is 95% POE oil. So you need a refractometer. You might have to do multiple oil change. You might have to do multiple filter changes. You purge while you're piping for sure. Make sure you have inert gas going through there so you don't plug up. Change the oil filter. If it has suction filters, I don't know, change those. Then afterwards, you might have to change the oil, like I said, a couple times. Then afterwards, you want to do an oil sample. After you get it up and running, you know the piping's proper, you know oil's coming back. You need to do an oil check just to make sure that it's 95.5, as well as that there's no moisture in the system to start off. Hopefully that helps.
Trevor, I
Yes,
have a
Victor.
question.
Yeah, go ahead.
Yes, if you see right now the transition going from the old refrigerant to the new refrigerant, I think it's better to change the system than if you are retrofitting from R22 to 448A, you're gonna have a lot of problem with leaks on the rubbers from even expansion valves, solenoid valves, whatever. It will take you more time to do those retrofit than to change the system. What do you think about it?
So Victor, I don't believe you need to change the whole system. And there's a few points that I'll have there is you need to plan. I see contractors that are doing retrofits that aren't planning, and I've heard of this, where it costs them way more money. They get in trouble. They have all these leaks. I have met other contractors that they plan, they quote properly, and do the proper retrofit. So just like you said, if you have rubbers in there, these are 20-year-old systems with R22, you're going to get leaks when you're changing to these new refrigerant, going from mineral to POE. You're going to have to. But you need a plan. So you need to spend the first week or 2 weeks planning, going to find where all the solenoid valves are that needs to be replaced, or the gaskets that need to replace, and if they need to be, checking all the TXVs if they need to be replaced or not. You know, are they going to work or not? Are they adjustable? Are they not adjustable? Will they work? You need to also make sure that you have a plan for the oil changes, changing the filters, changing. So if you're planning
Yes,
that retrofit properly,
yes, sure.
you'll be fine. Do you need to add demand cooling on the compressors or not? Because you may have, well, a 22 if it's low temp, they should have them, but
I don't know, but like in Canada, what's your electricity prices for kilowatt? Like here in Aruba, it's 32 cents. And
Wow.
if I, and 32 cents US dollar. But
wow.
if,
Yeah,
if you change your old system with old technology, you're still spending the same electricity.
Yep.
Without
100%.
Yeah, and that's why I mentioned changing the system for something newer that will be saving you electricity. Like for a supermarket, the more they save on utilities, the more profit they can do.
But there is still, even on older systems, they can put a VFD on the suction, on the compressor, or a digital compressor. And what that'll do is increase your suction pressure. And so if you can, every PSI you increase your suction pressure is like 2% more efficient.
Yeah.
So you can make your system more efficient, but you just need to figure out the strategy to do it. Are you going to gain more efficient? For sure. If you have a more efficient condenser, you have more efficient evaporators, for sure, it will be more efficient. But the cost to do a retrofit, to changing every case, all the piping, everything, it's hard to say. You know what I mean? There's no apples to apples comparison out there. I've looked up all the manufacturers saying this and this, but there's really, until that end user does it and you monitor M&V it, do all the studies, there's not many of those done out there that I know of. If anyone knows, please send it to me and I'll share it with everybody.
Yes, we did a retrofit on a 1994 Rock for a medium and low.
Yeah,
we changed one compressor on each one for a digital discus compressor, and with that we got a savings about $10,000 a month on electricity, and the investment they made to change those compressors compared to the electrical spending, they got paid the inversion in no time.
Yeah, highly recommend doing that. Yeah. And I don't know, what's the lowest temperature does it get in Aruba during the year? How low does your temperature get?
It's an average is 83 degrees Fahrenheit.
Year round?
Yeah, year round. That's
okay.
Average.
Yeah. Okay. So really low condensing. You're not going to do it there at all, even in the evenings. It's just too warm. But you could, if there's other newer things, especially like on the CO2 side, it does cost, but like maybe adiabatic cooling or misting systems to really help reduce that temperature, right? Is it going to work in that area? I don't know, to be honest with you, but it's something that you can look into to maybe add more value to the customer. But you got to do that. You got to check that stuff out to see if that's going to work.
Yeah, we have to check it out. I appreciate your comments.
No, you're very welcome. Thanks for the questions. I really appreciate that. So we're good. We're at 7:03. Kervin, I'm drinking Americano right now. This is an organic blend, but it's actually called Organica. It's It's pretty good coffee. I really enjoy it. I have a pile of coffee, different kind of beans and stuff because I bust them myself. But thanks for joining from the Philippines. I appreciate it. Okay, 7:04. Hopefully we shared some good information. There's a few things that I didn't touch on as for oil is defrost schedules. Defrost could cause oil not coming back. So maybe we'll bring that up a little bit in the next episode. Thank you very much for everyone joining, and let's get a conversation going.